All right, what is going on, guys? Mr. C here with lesson 10.5. Going to be talking about trigonometry and area today. Really, today is just kind of an extension of what we went over in 10.3. So we're going to be taking a look at regular polygons again, specifically ones that require SOHCAHTOA in order to solve. I remember in 10.3, they don't all require SOHCAHTOA. Depending on how many sides they have, the interior angles might be set up to where you can use special right triangles. But in this lesson today, we're going to need SOHCAHTOA in order to solve. So let's take a look. Here's my, here's my setup of my first problem. So it says, what is the area of a regular octagon with 7.5 centimeter sides? Okay, 7.5 centimeter sides. So if you recall, the area for a regular polygon was 1/2 the apothem times the perimeter. All right, and the apothem was the distance here of that triangle. Okay, remember you set it up and there's like 8 triangles in the octagon. Find the area of one of them, multiply that by 8, or you can use this formula here. Will give us the area of the octagon. So we are going to need to find this here, which is the apothem. But let's find the perimeter first. That's the easy one because we know side lengths are 7.5. And we know we have 8 of them. Okay. 7 times 8 is 56, and then 8 times 1/2 is 4, so it's 56 plus 4. That should be 60 centimeters for the perimeter. Now the apothem, again, that is this distance here. In order to find that, we do need to kind of use this right triangle here, which I'm going to draw separately. So I'm talking about this guy here, okay? All right. How do we find, I'll call that y. How do we find this distance here? Well, we're going to need a couple things. If this here is 7.5 and we cut that in half, okay, what does that mean that side length is going to be? 7.5 divided by 2. Okay, I have a 3.75. Okay, again, that's this distance here, which is right here. This is 3.75. Okay. Now, in order to find what y is, we're going to use SOHCAHTOA, but we need to find what is this angle here. Okay, what is this angle here? And if you recall, to find this full angle from here to here, okay, to find this portion, we do 360 divided by, there's 8 of them inside the octagon, so let's figure out what that is. 360 divided by 8, okay, gives me a 45. So this angle is 45, but that's not the angle we want. We want half that angle. So 45 divided by 2 now is 22.5. Okay, that's right here. 22.5 degrees, which if we're trying to use this triangle here, we have 22.5 degrees for that angle. All right, so we're trying to use SOHCAHTOA. We have this angle here. We have the opposite side. We're trying to find the adjacent side. So if you remember, SOHCAHTOA, opposite and adjacent goes with tangent. So we have the tan of 22.5 equals opposite is 3.75 over adjacent is that y. Okay. Multiply both sides by y, so we have y times the tan, 22.5 equals 3.75, and then divide both sides by the tan of 22.5. So y will equal 3.75 divided by the tan, 22.5. Okay, tan of 22.5. So let's calculate that. Make sure my calculator's in degree mode. It's in radians right now, so change it back to degrees. So we have 3.75 divided by the tan of 22.5. Okay. Get a 9.05. We'll run that to 9.1 for my y, which technically is my We said that's the distance here. That's my apothem. Okay, so we have a 9.1. And then we have everything we need. We have the apothem. We have the perimeter. Let's plug that in. We have 1/2 of 9.1 times the perimeter is 60. So 60 times 9.1 divided by 2 gives me a 273, right? 273 centimeters squared. Okay, it's an approximate. We did some rounding there, but we have 273 centimeters squared. Okay. All right, so you guys are going to be practicing those for the first lesson, and then we have one more formula we're going to learn. But if you are just doing today's lesson, go ahead and take a break here, do the first homework assignment, and then we are going to continue on with tomorrow's. All right, so that concludes today's. All right, for the next day, let us go over a new formula. Just one more thing we need to learn for this lesson, and then we will be good. There's actually a separate, there's a couple different formulas for area of a triangle, but this is another one. It's not 1/2 base times height. It is, let's see, we have a triangle. Okay, so area formula for SAS triangles. Okay, area formula for SAS triangles. Now, if we're not given the height, but we're given a side, or I should say 2 sides and the angle in between them, there is another formula we can use to find the area of a triangle. Okay, let's say this is A, B, C. We have little a, little b, and little c. Okay, we do have another area formula, and it is 1/2 BC times the sine of A. And it doesn't necessarily have to be BC sine A. It could be AB sine C. It could be CA sine B. But as long as you're doing, like in this case, you have the 2 sides, C and B, and the angle between them. Okay, so 2 sides, C and B, and the angle between them. If you multiply that out, divide that by 2, that's going to give you the area. So kind of why that works, if you're curious, is if I was to set this up here, okay, if I was to set that up, now this is H here. Okay, that's my height of my triangle. Think about the area just being 1/2 the base B times the height H. Okay. Also, what is the sine of angle A in this picture? Okay, so we have this right triangle here. The sine of angle A is H over C. H over C. Okay, recall that's, here's angle A, it's opposite side over the hypotenuse side. Now it's kind of cool, if we multiply in this equation both sides by C, you should have C times the sine of A is equal to H. Now what we can do in our original, you guys recognize this one, 1/2 base times height. Okay, we can take C times sine A, and since that is equal to height, this whole portion here, C sine A, goes in for H in my original equation and gets substituted in. And that's how we get the area formula that we have, we're going over right now, the side angle side formula. So 1/2 BC sine A. This C sine A is technically H, which is why this formula is working. That's where it comes from, if you're curious. This 1/2 BC sine A comes from, this is kind of like the proof for it here. Since the sine of A is H over C, multiply both sides by C, you get height equal to C sine A. Replace it, and then this is our new formula. Okay, so if that doesn't really make sense how this works and how you replace the H with sine C, don't worry, as long as you have this formula, you're good to go. But that was just kind of proving it to you, showing you why it works. So, an example of how we would use this. Let's take a look at this triangle here. All right, so let's say we have 16-inch side here. We have a 10-inch side here, and this is 34 degrees. If we want to find area, okay, this is one of those side angle side situations where we don't have to have the height. We can use this formula here instead to find it. So it's really just a matter of, do you know the formula? Can you plug it in? So we should have 1/2 16 times 10 times the sine of 34. Okay, and really that's all we need to do. So let's go to our calculator. 16 times 10 times the sine of 34, and then divide that answer by 2. Okay, and that is 44.7. Area 44.7 inches squared. All right. So it's as simple as that. Either you know the formula or you don't. Again, this is used for side angle side situations. 1/2 BC sine A. Okay. And really that just is all we're going over today. Just this one formula, okay, that we're adding. So yeah, that's it. Let me know if you guys have any questions on this stuff. Not too difficult, this part here. Just plug in the formula. Miss you guys. Hope you guys are doing well. Don't forget to wash your hands. And we'll talk to you next time. Peace.